At 4:17 in the morning on April 10, 1942, Technical Sergeant Jose Calugas stood in a camouflaged clearing deep in the Zambales mountains of Luzon, Philippines, watching the last American transport aircraft disappear into the darkness toward Australia. The aircraft carried officers, staff personnel, and essential records, but it did not carry spare parts, maintenance equipment, or any provisions for the men left behind. Calugas was 28 years old, a maintenance specialist with the Philippine Army Air Corps who had been working alongside American forces since December. He had maintained Curtiss P-40 Warhawks for 4 months under increasingly desperate conditions, and now, with Bataan fallen and Corregidor about to collapse, he faced an impossible situation. Hidden in the jungle around him were 19 P-40 fighters that had been damaged in combat or forced down by mechanical failure, aircraft that had been abandoned by retreating American forces who lacked the parts and time to repair them. Most had been officially written off as total losses, and the Army Air Force's maintenance manual said these aircraft were beyond field repair. The engineering specifications were clear. Damaged engine mounts required factory replacement, cracked cylinder heads needed depot-level service, and torn control surfaces demanded specialized tools and materials unavailable outside the United States. But Calugas had 47 Filipino mechanics under his command, a jungle full of aircraft wreckage, and a Japanese occupation force that would kill them all if discovered. He also had something the manual writers never anticipated: 8 years of experience maintaining engines in the Philippine countryside where spare parts never arrived, and improvisation meant survival. What happened over the next 8 months would prove that sometimes the most important military technology isn't advanced equipment or sophisticated weapons, but the knowledge of how to keep fighting when the supply chain disappears and the rulebook becomes irrelevant. The P-40 Warhawk was never supposed to be a frontline fighter in 1942, and by the time Japan attacked Pearl Harbor, the aircraft was already considered obsolescent by American standards. The Curtiss-Wright Corporation had designed it in 1938 as an interim fighter, while better aircraft were developed, and the P-40 was heavier and slower than Japanese fighters. It couldn't climb as fast, it couldn't turn as tightly, and the Mitsubishi A6M0 could execute a full horizontal turn in half the time a P-40 needed. But the P-40 had advantages that mattered in the Pacific. It was tough, the airframe could absorb tremendous damage and keep flying, and the Allison V1710 engine was reliable if properly maintained. The aircraft had self-sealing fuel tanks and armor protection for the pilot, but most importantly, for Calugas's situation, the P-40 was designed for field maintenance. The engine could be removed and replaced in less than an hour with proper equipment, access panels provided easy reach to critical systems, and the landing gear was simple and robust. When the Philippines campaign began in December 1941, the United States Army Air Forces had approximately 107 P-40s stationed across the islands, but most were destroyed on the ground during the first Japanese attacks. The survivors fought desperately against overwhelming odds, and by January 1942, only a handful remained operational. Pilots flew them until they ran out of ammunition or fuel, or until mechanical failure forced them down, but there were no replacement parts. The supply ships that should have brought equipment and materials had been sunk or diverted to Australia. The maintenance depots had been bombed, and the spare parts warehouses had been destroyed or captured. American mechanics did what they could with what they had. They cannibalized destroyed aircraft for parts. They improvised repairs using materials never intended for aircraft, and they kept fighters flying through ingenuity and desperation. But by April, even that wasn't enough, as the operational P-40s had been evacuated or destroyed to prevent capture, and the damaged ones were abandoned. That's where Jose Calugas entered the story. Having been born in Pampanga province in 1914, the son of a farmer who also worked as a diesel engine mechanic for the Provincial Transportation Department. Calugas grew up around engines, and by age 12 he could rebuild a carburetor, while by 15 he was helping his father maintain the aging trucks and tractors that kept the local economy functioning. In the Philippines during the 1920s and 30s, spare parts for mechanical equipment rarely arrived from overseas because import costs were prohibitive and shipping took months. Equipment that broke down had to be fixed with whatever materials were locally available, and this created a culture of mechanical improvisation. Filipino mechanics became extraordinarily skilled at fabricating replacement parts from scrap metal, adapting components from different machines, and keeping equipment running long past its intended service life. Calugas learned these skills from his father and from the other mechanics in their community, and when he joined the Philippine Army Air Corps in 1934, he brought that knowledge with him. The Philippine Army Air Corps was tiny by international standards, and in 1934 it possessed fewer than 20 aircraft, most of them obsolete trainers and observation planes left over from World War I. Maintenance was a constant challenge, as spare parts had to be ordered from the United States and took 6 months to arrive if they arrived at all. Aircraft sat grounded for weeks, waiting for a single component that cost $5 but was unavailable anywhere in the Philippines. Calugas watched American advisors struggle with this reality. They had excellent technical training and understood aircraft systems in detail, but they were trained to maintain equipment according to manuals that assumed unlimited access to factory parts. When parts weren't available, many American mechanics simply declared the aircraft unserviceable and waited for supplies, but Calugas took a different approach. If a carburetor jet was clogged and no replacement was available, he would fabricate a new one from brass stock, matching the dimensions by eye and testing it until it worked. If a fuel line cracked, he would repair it with rubber from old tires and steel wire. And if an electrical connection failed, he would bypass it with hand-soldered joints. The repairs weren't pretty and wouldn't pass inspection in the United States, but they worked, and aircraft that American mechanics had declared beyond repair would be flying again within days under Calugas's hands. By 1940, he had earned a reputation as the best aircraft mechanic in the Philippine Army Air Corps, and when the United States began reinforcing the Philippines in 1941, Calugas was assigned to work with American maintenance crews at Nichols Field near Manila. The Americans were impressed by his skills, but troubled by his methods. He didn't follow the technical orders, he didn't use the specified tools, and he made repairs that the manuals said were impossible. An American master sergeant told him directly that his improvised repairs violated regulations and could result in aircraft accidents. Calugas replied that aircraft sitting on the ground because they were waiting for parts would certainly not fly, and that seemed worse than the theoretical risk of a properly tested field repair. The debate became moot on December 8, 1941, when Japanese aircraft struck Clark Field and Nichols Field in devastating attacks that destroyed most American air power in the Philippines within hours. Suddenly, every aircraft that could be made airworthy was desperately needed, and nobody cared whether repairs followed regulations. Calugas worked 18-hour days repairing damaged aircraft, salvaged parts from destroyed planes, fabricated components from sheet metal and wire, and kept fighters flying through methods that would have horrified inspectors in peacetime. As American forces retreated to Bataan in January 1942, Calugas went with them, helping establish hidden airstrips in the jungle where damaged aircraft could be repaired away from Japanese observation. He trained Filipino mechanics in improvised repair techniques and organized salvage teams that recovered parts from crashed aircraft in no man's land between American and Japanese lines. By March 1942, the situation had become hopeless. American forces on Bataan were starving and running out of ammunition, and the few remaining aircraft were evacuated to Mindanao or Australia. The damaged ones were left behind, and most were destroyed to prevent capture. But 19 P-40s in various states of disrepair had been hidden in a remote valley in the Zambales Mountains. They had been camouflaged under jungle canopy and forgotten, and American commanders assumed they would be discovered and destroyed by the Japanese. Calugas knew about these aircraft and had helped hide some of them, and after the American evacuation he made a decision that would define the rest of his war. He would stay in the mountains with the hidden P-40s and try to make them flyable, a decision that was not made lightly. Staying meant becoming a fugitive in Japanese-occupied territory, living in the jungle with minimal supplies and no communication with Allied forces, and facing execution if captured. But Calugas believed the aircraft could be salvaged. He knew how to fabricate parts. He had access to wreckage from dozens of destroyed aircraft scattered across the region, and he had skilled Filipino mechanics willing to work with him. Most importantly, he understood something that the American commanders who had abandoned the aircraft did not. In the Philippines, nothing was truly unrepairable if you were willing to improvise. 47 Filipino mechanics stayed with Calugas. Some were Philippine Army Air Corps personnel like him. Others were civilian mechanics who had worked at Clark Field and Nichols Field before the war, and a few were simply villagers with mechanical aptitude who wanted to continue resisting the Japanese occupation. They established a hidden camp in the valley where the P-40s were concealed, a location that was remote and accessible only by narrow jungle trails that Japanese patrols rarely used. The valley had a small stream for water, dense jungle canopy provided natural camouflage, and local villagers, many of whom were relatives of the mechanics, provided food and warned of Japanese patrols. Calugas organized his team into specialized groups. One group focused on engine work, another handled airframe repairs, a third worked on electrical systems and instruments, and a fourth group was responsible for salvage operations. The salvage work was the most dangerous, as teams had to move through Japanese-occupied territory to reach crash sites, traveling at night and carrying hand tools while avoiding roads and settlements. When they found a crashed aircraft, they would strip it of any useful components, working as quickly and quietly as possible, and the salvaged parts were carried back to the hidden valley on their backs, sometimes requiring multiple trips over several nights. Over 8 months, Calugas's salvage teams recovered parts from more than 30 destroyed aircraft, bringing back propellers, instruments, control cables, hydraulic components, engine parts, and hundreds of smaller items. They also recovered tools from abandoned maintenance facilities, including welding equipment, drill presses, and hand tools that would prove essential for fabricating parts. The condition of the 19 hidden P-40s varied dramatically. 5 aircraft had relatively minor damage and needed new tires, fresh fuel, and some electrical repairs before they could probably fly. 7 aircraft had moderate damage, including cracked engine mounts, damaged landing gear, and torn control surfaces that would require significant work but were salvageable. The remaining 7 were in terrible condition, as battle damage, hard landings, and months of exposure to tropical weather had taken their toll, and several had engines that had been damaged beyond any reasonable hope of repair. Others had structural damage that the maintenance manual said required depot-level facilities to fix, so Calugas made a strategic decision. The 7 worst aircraft would be used as parts donors, completely disassembled, and every serviceable component would be catalogued and stored for use in repairing the other 12 aircraft. This was practical cannibalization taken to an extreme level, and over the next 2 months, Calugas's mechanics systematically stripped the 7 aircraft down to their basic airframes. They removed engines, propellers, landing gear, control surfaces, instruments, radios, guns, ammunition boxes, fuel tanks, hydraulic lines, electrical wiring, seat cushions, and even structural components like longerons and ribs. Everything was cleaned, inspected, and organized, and Calugas established a crude parts inventory system where components were sorted by type and stored in different areas of the camp. Engines were placed under tarpaulins in a sheltered area, small parts were kept in salvaged ammunition boxes, and instruments were wrapped in cloth and stored in a dry tent. The organization was essential because without it, the mechanics would waste precious time searching for needed components, and the first major challenge was the engines. The Allison V1710 was a liquid-cooled V12 engine that produced 1,150 horsepower, and it was sophisticated, powerful, and temperamental, requiring precise maintenance and high-quality lubricants. Several of the P-40 engines had been damaged by combat, mechanical failure, or simply sitting idle in tropical humidity for months, with cylinder heads cracked, crankshafts scored, and pistons seized in their cylinders. The maintenance manual said these engines required complete factory overhaul, a process that involved specialized equipment, precision measuring tools, and replacement parts that simply didn't exist in the Philippine jungle. Calugas approached the problem systematically. He had his mechanics disassemble every damaged engine completely, laying out all the components for inspection. They identified which parts were serviceable, which could be repaired, and which were beyond salvage, and then Kalugas began the painstaking process of rebuilding engines from the available parts. Air crankshaft from one engine would be matched with pistons from another and cylinder heads from a third, creating hybrid engines assembled from multiple donors. The process required extraordinary precision. Engine components had to fit together with tolerances measured in thousandths of an inch, and without proper measuring tools, Kalugas relied on feel and experience. He would test fit components repeatedly, filing and adjusting until everything meshed properly, and then he would assemble the engine and test it by hand, rotating the crankshaft to ensure smooth operation. The most challenging repairs involved fabricating parts that couldn't be salvaged from existing engines, and one critical component was the valve springs. The V1710 had 48 valves, and each valve required 2 springs to ensure it closed properly at high engine speeds, but many of the springs had weakened or broken after months of exposure to humidity. Kalugas couldn't manufacture new valve springs with the tools available, but he discovered that springs from salvaged Japanese motorcycles had similar characteristics. His mechanics collected springs from abandoned Japanese vehicles, tested them for tension, and modified them to fit the P-40 engines, a solution that the Allison engineering department would never have approved. But it worked, and the modified springs held up under testing, allowing the engines to run at operational speeds without valve float. Another critical problem was the engine coolant system, as the V1710 used a mixture of water and ethylene glycol as coolant, but the ethylene glycol had long since been exhausted. Using pure water as coolant would work temporarily, but it would cause corrosion in the engine's aluminum components and would freeze at high altitudes. Kalugas experimented with additives to improve the water's properties, and he discovered that adding alcohol distilled from local sugar cane provided some antifreeze protection and reduced corrosion. It wasn't as good as proper ethylene glycol, but it was significantly better than pure water, and it allowed the engines to operate at higher altitudes without freezing. The carburetor presented another challenge, as the Allison V1710 used a complex carburetor that metered fuel precisely across a wide range of altitudes and power settings. Several carburetors had been damaged or had internal components that had corroded, and rebuilding them required tiny jets and needles that couldn't be fabricated with the available tools. Kalugas solved this by cannibalizing the best components from multiple carburetors, creating hybrid units that worked well enough for the engines to run, though not necessarily at peak efficiency. He accepted that the repaired engines wouldn't produce their full rated horsepower, but 900 horsepower was better than 0, and it was enough to make the aircraft flyable. By July 1942, Kalugas's team had rebuilt 6 complete engines, each one a unique assembly of parts from multiple donors, held together by improvised repairs and sheer mechanical ingenuity. The first engine start was scheduled for dawn on July 12, 1942, chosen because the early morning air was coolest and because any noise would be less likely to attract Japanese attention. The engines were installed in 6 of the least damaged P-40 airframes, and then came the moment of truth, starting the engines and seeing if they would run. Kalugas personally performed the start procedure, priming the engine, setting the magnetos and engaging the starter. And for a long moment, nothing happened except the whine of the electric starter motor. Then the engine coughed, backfired, and roared to life with a sound that echoed through the valley like thunder, a sound that 47 Filipino mechanics had been working toward for 3 months. The engine ran rough at first, missing on several cylinders, but as it warmed up, it smoothed out and settled into a powerful, steady rumble that shook the entire airframe. Kalugas let it run for 5 minutes, monitoring oil pressure, coolant temperature, and listening for any signs of internal problems, and the engine performed flawlessly. Over the next 3 days, all 6 rebuilt engines were started and tested, and 5 of them ran well enough to be considered operational, though one continued to have persistent misfiring that Kalugas couldn't diagnose. But 5 running engines meant 5 potentially flyable P-40s, and that was 5 more fighters than the Allies had believed existed in the Philippines. However, getting the engines to run was only the first step, as the aircraft still needed extensive work on their airframes, control systems, landing gear, and dozens of other components before they could fly safely. The airframe repairs presented different challenges than the engine work, as the P-40's structure was built from aluminum alloy, a material that couldn't be welded with the oxyacetylene equipment Kalugas had available. Structural repairs required riveting, but the mechanics had only a limited supply of aluminum rivets salvaged from destroyed aircraft, and those had to be used sparingly. Several P-40s had damaged wing spars, the main structural members that carried the wing's flight loads, and the maintenance manual said damaged spars required complete wing replacement. Kalugas didn't have replacement wings, but he did have salvaged aluminum and the ability to fabricate reinforcement plates, so he designed a repair technique that involved splinting the damaged areas. His mechanics would cut reinforcement plates from salvaged aluminum sheet, drill them to match the original structure, and rivet them in place to strengthen the damaged sections. The repairs added weight and weren't as strong as the original structure, but testing showed they could handle the loads imposed by normal flight maneuvers. Kalugas accepted that the repaired aircraft wouldn't be able to perform violent aerobatic maneuvers or pull maximum G loads, but they could fly, and that was what mattered. The control surfaces presented another challenge, as several P-40s had fabric-covered ailerons, elevators and rudders that had rotted away after months of exposure to tropical rain and humidity. The aircraft fabric used for covering control surfaces was a specialized material treated with cellulose dope to make it tight and waterproof, but that material was unavailable. Kalugas experimented with alternatives and eventually settled on a solution that seemed almost absurd. He would use parachute silk salvaged from destroyed aircraft and supply drops. The silk was strong, lightweight, and could be stretched tight over the control surface frames, and his mechanics sewed the silk into place, pulling it tight and securing it with hundreds of hand-stitched seams. Then they treated the silk with a mixture of tree sap and alcohol to waterproof it and give it some rigidity, a technique that Kalugas had learned from boat builders in his home province. The result looked crude and wouldn't survive for long, but it was strong enough for flight, and the silk covering could be replaced relatively easily when it wore out. The landing gear was perhaps the most critical system after the engine, as a P-40 that couldn't take off or land safely was useless, regardless of how well the rest of it worked. Several aircraft had damaged landing gear struts, bent wheels, or failed hydraulic systems that operated the gear retraction mechanism. The landing gear struts were made from high-strength steel and couldn't be straightened without specialized equipment, but Kalugas discovered he could swap struts between aircraft to assemble complete sets. The wheels were more problematic, as several had been bent or cracked in hard landings, and aircraft wheels had to be perfectly round and balanced to prevent dangerous vibrations during takeoff and landing. Kalugas's solution was to machine the damaged wheels back into round, using a hand-cranked lathe salvaged from an abandoned machine shop in a nearby town. The work was tedious, as each wheel had to be carefully measured and machined, but eventually the mechanics produced 6 serviceable wheel sets that ran true enough for safe operation. The tires were completely gone, rotted away or damaged beyond repair, and aircraft tires were highly specialized items that couldn't be improvised or substituted easily. Kalugas initially thought this problem might be insurmountable, but then he remembered that the Philippine constabulary had been using trucks with similar-sized wheels before the war. He sent salvage teams to locate abandoned constabulary vehicles, and they eventually found 3 trucks that still had serviceable tires, truck tires that weren't designed for aircraft but had the right diameter. Kalugas modified the P-40 wheels to accept the truck tires, and while they were heavier than proper aircraft tires and wouldn't last as long, they would work for the limited operations he was planning. The hydraulic system that operated the landing gear, flaps and brakes had deteriorated in many aircraft, with seals dried out, lines cracked, and fluid contaminated or completely evaporated. Proper aircraft hydraulic fluid was unavailable, but Kalugas discovered that a mixture of automotive brake fluid and light machine oil produced adequate results. His mechanics replaced or repaired every hydraulic line, using copper tubing salvaged from destroyed aircraft and fabricating new fittings from brass stock when necessary. They rebuilt hydraulic cylinders using salvaged seals and O-rings, and while the repaired system leaked slightly more than it should, it maintained enough pressure to operate reliably. The electrical system presented unique challenges, as the P-40's 12-volt electrical system powered everything from the starter motor to the instruments to the radio. Many aircraft had damaged or corroded wiring, failed generators or dead batteries, and rewiring an aircraft required understanding complex electrical diagrams that most of the mechanics couldn't read. Kalugas solved this by creating a master P-40 from the best electrical components available, using it as a template to repair the others, and his electricians would trace circuits in the master aircraft. They marked each wire and connection, then replicated the same configuration in the aircraft being repaired. And it was slow work, but it ensured that the electrical systems functioned correctly. The batteries were completely dead and couldn't be recharged, so Kalugas's mechanics built new batteries from scratch, using lead plates salvaged from vehicle batteries. They constructed cases from wood and rubber, filled them with sulfuric acid obtained from old truck batteries, and assembled them into 12-volt units that could provide enough current to start the engines. The homemade batteries were crude and had less capacity than factory units, but they worked, and that was another impossible problem solved through improvisation. The instruments were another critical concern, as most P-40 cockpits had more than 24 instruments providing information about engine performance, flight attitude, altitude, airspeed, and fuel quantity. Many instruments had failed or were giving incorrect readings, which would make the aircraft dangerous to fly, especially in poor weather or at night. Kalugas prioritized the most essential instruments: the airspeed indicator, altimeter, engine tachometer, oil pressure gauge, and coolant temperature gauge. He had his mechanics test every instrument from every aircraft, identifying which ones still worked accurately, and then they installed the best instruments in the aircraft they were preparing to fly. Some instruments could be repaired by cleaning corrosion or replacing internal springs, and Kalugas became skilled at disassembling the delicate mechanisms and restoring them to working order. The magnetic compass was essential for navigation, but most had developed air bubbles in their fluid or had their magnetic elements damaged. Kalugas's mechanics refilled the compass housings with alcohol, mixed with a small amount of water, to prevent freezing, and they remagnetized the compass elements using salvaged magnets. By September 1942, 5 months after beginning their work, Kalugas's team had 3 P-40s that they believed were ready for flight testing. The aircraft had been rebuilt from dozens of wrecks, powered by hybrid engines, covered with parachute silk and equipped with truck tires. Nothing about them met Army Air Force's specifications, and everything about them violated maintenance regulations, but Kalugas believed they would fly. The challenge now was finding someone who could test fly them, as none of Kalugas's mechanics were pilots, and they had no contact with any American or Filipino pilots who had survived the fall of the Philippines. This problem was solved by Captain Jesus Villamor, one of the Philippine Army Air Corps' most experienced pilots, who had been leading a guerrilla resistance group in the mountains. Villamor had heard rumors about hidden aircraft being repaired in the Zambales Mountains, and in late September, he made contact with Kalugas's group. What Villamor found astonished him: 3 P-40 fighters that looked like they had been assembled from spare parts and imagination, sitting in a camouflaged clearing and apparently ready to fly. Kalugas briefed Villamor on the repairs, explaining which systems were fully functional, which were improvised, and which had known limitations. The engines would produce about 80% of normal power. The control surfaces were covered with parachute silk that might not survive high-speed flight, and the landing gear was fitted with truck tires. The aircraft could not perform aerobatics, could not dive at high speed, and probably could not sustain combat against Japanese fighters, but they could fly. Villamor examined the aircraft carefully and made his decision. He would test fly one of them, and if it worked, they would make plans to use the others. The test flight was scheduled for dawn on October 3, 1942, and the mechanics had cleared a rough airstrip in the valley, removing the largest rocks and filling the worst holes. It was barely 800 meters long, marginal for a P-40, but it would have to do, and Villamor performed a thorough pre-flight inspection, checking every system Kalugas had described. At 6:12 in the morning, with 47 Filipino mechanics watching from the jungle edge, Villamor started the engine, and it caught immediately and settled into a rough but steady rumble. He let it warm up for 5 minutes, checking instruments and testing the controls, and then he released the brakes and began his takeoff roll. The P-40 accelerated slowly on the rough strip, bouncing over uneven ground, and for a moment it seemed it wouldn't get airborne before running out of runway. Then Villemot pulled back on the stick, and the aircraft lifted off with perhaps 50 meters of runway remaining, climbing slowly into the morning sky. Kalougas watched the aircraft climb, holding his breath, waiting for something to fail, but the P-40 continued climbing steadily to about 1,000 meters. Villemot spent 20 minutes testing the aircraft, trying gentle turns, checking the controls, monitoring the engine, and when he brought it back for landing, his approach was perfect. The P-40 touched down smoothly, the truck tires held, and the aircraft rolled to a stop at the end of the strip. And when Villemot climbed out of the cockpit, he was smiling. He told Kalougas the aircraft flew better than he'd expected. The engine ran well, the controls responded properly, and the improvised repairs held up under flight loads. The aircraft vibrated more than normal, the engine was down on power, and the landing gear made alarming noises, but it was flyable, genuinely flyable. Over the next 2 weeks, Villemot test flew all 3 rebuilt P-40s, and each one performed adequately, and then he proposed a plan that seemed insane but possible. They would use the aircraft to attack Japanese installations, focusing on targets where fighter opposition was unlikely: supply depots, truck convoys, isolated outposts. The P-40s couldn't fight Zeros, but they didn't need to, as they just needed to strike targets and escape before Japanese fighters could respond. Kalougas supported the plan, but warned that the aircraft had severe limitations. They could only operate for short periods before requiring maintenance, and spare parts remained critically scarce. Every flight would cause wear that would be difficult to repair, and eventually, the aircraft would break down beyond their ability to fix them. Villemot accepted these limitations, arguing that even a few successful strikes would boost Filipino morale and prove that resistance was still possible. The first combat mission launched on October 28, 1942, when Villemot took off alone in one of the rebuilt P-40s to attack a Japanese supply convoy on the coastal road near Olongapo. He approached at low altitude, strafed the convoy with his machine guns, and climbed away before the surprised Japanese could respond effectively. He destroyed 3 trucks and damaged several others, and then he returned to the hidden airstrip, where Kalougas's mechanics immediately swarmed over the aircraft. The mission had caused predictable problems. One cylinder was misfiring, several rivets on the wing had loosened from vibration, and one of the truck tires had picked up a slow leak. Kalougas's team worked through the night repairing the damage, and by dawn the aircraft was ready to fly again, though Kalougas knew they couldn't sustain this pace indefinitely. Over the next 3 months, Villemot and 2 other Filipino pilots who joined the group flew 17 combat missions in the rebuilt P-40s. They attacked supply convoys, strafed Japanese encampments, destroyed parked aircraft at small airfields, and disrupted enemy communications. The missions were carefully planned to minimize risk. The pilots would strike quickly and escape before Japanese fighters could intercept them. They operated at dawn or dusk when visibility was poor. They avoided areas with heavy anti-aircraft defenses, and they never stayed in one area long enough to be tracked. The psychological impact on the Japanese was significant, as they believed they had destroyed all American aircraft in the Philippines months earlier. The sudden appearance of P-40 fighters attacking their supply lines created confusion and forced them to divert resources to air defense. Japanese intelligence reports from late 1942 mention mysterious American fighter attacks in areas where no aircraft should have been able to operate. They assumed the aircraft were flying from hidden airfields supplied by submarine, and they never discovered the truth about Kalougas's jungle workshop. But the operations took a severe toll on the aircraft, as each mission caused damage that became progressively harder to repair. Engines wore out, control surfaces tore, landing gear failed, and the supply of salvageable parts was diminishing rapidly. By January 1943, only 2 of the 3 aircraft remained operational, and both were in questionable condition. Kalougas pushed his team to keep working, rebuilding components that had already been rebuilt multiple times, fabricating parts from increasingly inadequate materials. One engine was running on only 10 of its 12 cylinders, because 2 had failed and couldn't be repaired, and another aircraft had a wing spar crack that was slowly growing despite repeated reinforcement. The mechanics knew they were pushing the aircraft beyond any reasonable safety margin, but stopping meant surrendering the small advantage they had gained. On February 17, 1943, disaster struck when one of the P-40s suffered a complete engine failure during a mission and crashed while attempting to return to base. The pilot, Lieutenant Ricardo Cruz, survived the crash with minor injuries, but the aircraft was destroyed, and it was a total loss beyond any possibility of salvage. Kalugas examined the wreckage and determined that the engine failure had been caused by a crankshaft that had finally fractured after months of operating under stress it was never designed to handle. The loss reduced them to a single operational P-40, and that aircraft was in barely flyable condition, with multiple systems operating at the edge of failure. Villamor made the decision to suspend operations until Kalugas could assess whether any of the remaining aircraft could be made airworthy. Kalugas spent 3 weeks surveying his resources. He had 9 P-40 airframes that hadn't yet been cannibalized, but all had significant damage. He had parts salvaged from the crashed aircraft. He had components recovered from sites across the region, and he had the accumulated knowledge of 8 months of improvised repairs. He told Villamor he could probably rebuild 3 more aircraft, but it would take at least 2 months, and they would be in even worse condition than the first batch. The engines would be weaker, the airframes more fragile, and the probability of mechanical failure higher, but they would fly, at least for a while. Villamor gave him authorization to proceed, and Kalugas's team began their most ambitious rebuilding effort yet. They stripped 3 of the least damaged airframes down to bare metal, assessed every component, and began the painstaking process of reconstruction. This time, they had to be even more creative because the supply of good salvaged parts had been exhausted, and what remained was increasingly marginal. Kalugas fabricated engine mounts from salvaged steel beams. He repaired cracked aluminum panels, using riveted patches made from flattened food tins. He built fuel lines from copper tubing scavenged from destroyed buildings, and he created control cables from braided steel wire salvaged from suspension bridges. Every repair was more improvised than the last, every solution more desperate, but slowly, impossibly, the aircraft took shape. By late April 1943, 2 of the 3 aircraft were complete enough to attempt engine runs, and both engines started, though they ran rough and produced even less power than the previous batch. Kalugas estimated they were producing perhaps 65% of rated horsepower, which would severely limit the aircraft's performance, but it was still enough to fly. The 3rd aircraft was taking longer because it had structural damage that required extensive repairs to the main wing spar, work that demanded precision Kalugas couldn't quite achieve with the tools available. On May 8, 1943, Villamor test flew one of the newly rebuilt P-40s, and the flight revealed the aircraft's limitations immediately. It was sluggish, slow to respond, and vibrated constantly, but it flew, and Villamor declared it adequate for the limited missions they were planning. However, the strategic situation had changed dramatically since October 1942, as American forces were advancing through the Pacific and the Philippines would eventually be liberated. Villamor decided the remaining P-40s should be preserved rather than risked in combat, as they represented a unique achievement that deserved to be documented. The aircraft were hidden in a remote cave system in the mountains, carefully preserved with the intention of recovering them after the liberation. Kalugas and his mechanics continued their work, maintaining the hidden aircraft and preparing for the eventual return of American forces. In October 1944, American forces landed at Leyte, beginning the liberation of the Philippines, and Kalugas's group made contact with advancing American units in December. They guided American officers to the hidden cave, where 2 P-40s remained in flyable condition, aircraft that had been written off as total losses more than 2 years earlier. The American engineers who examined the aircraft were astounded by what they found, as the P-40s were unlike anything they had ever seen. Hybrid engines assembled from multiple donors, airframes repaired with improvised materials, systems that violated every regulation in the maintenance manual but somehow worked. One American major wrote in his report that the aircraft represented the most extraordinary example of field maintenance improvisation he had encountered in the entire war. The report documented Kalugas's methods in detail, including the use of parachute silk for control surfaces, truck tires for landing gear, and homemade batteries. The Army Air Force's technical intelligence officers photographed everything, collected samples of the improvised components, and interviewed Kalugas extensively about his techniques. They wanted to understand how he had achieved what trained American mechanics had declared impossible, keeping fighters operational without spare parts, proper tools, or factory support. Kalugas explained his philosophy. The maintenance manuals assumed access to unlimited resources, but in the Philippines, resources were never unlimited. Filipino mechanics had learned to make things work with whatever was available, to improvise solutions when proper parts didn't exist, and to accept that adequate repairs were better than no repairs. The Americans had excellent training and understood aircraft systems perfectly, but they had been taught that repairs had to meet specifications or the aircraft was unserviceable. Kalugas had learned that specifications were guidelines, not absolute limits, and that an aircraft that flew at 70% efficiency was infinitely more useful than an aircraft that sat grounded waiting for proper parts. The technical intelligence report concluded that Kalugas's work demonstrated principles that should be incorporated into military maintenance doctrine for operations in austere environments. The report recommended that mechanics receive training in improvisation, that field units be equipped with basic fabrication tools, and that maintenance regulations allow more flexibility for emergency repairs. But as with many wartime innovations from unconventional sources, the recommendations were largely ignored by the Army Air Force's bureaucracy. Kalugas received a commendation for his work, but no medal, no promotion, and no official recognition beyond a paragraph in a classified technical report. His name didn't appear in any histories of the Philippines campaign, and the story of the rebuilt P-40s was classified for security reasons that no longer made sense after the war ended. The two surviving P-40s were eventually recovered from their cave and transported to a depot in Manila, where they were examined by engineers and then unceremoniously scrapped. No museum wanted them because they were too modified to represent authentic P-40 configuration, and no historian had documented their unique story. They disappeared into the salvage system, just more wreckage from a war that had produced mountains of wreckage. After the war, Kalugas returned to Pampanga province and resumed his pre-war occupation, working as a diesel mechanic for the Provincial Transportation Department. He married in 1947, had 5 children, and continued working on engines until he retired in 1979 at the age of 65. He rarely talked about his wartime experiences, and when people asked, he would say he had been a mechanic who fixed airplanes, nothing special. The 47 Filipino mechanics who had worked with him scattered across the Philippines after the war, returning to their families and pre-war occupations. Some became civilian aircraft mechanics, others worked on automobiles or machinery, and a few continued serving in the Philippine Air Force. None received significant recognition for their work, and most never told their families the full story of what they had accomplished in the Zambales Mountains. Captain Jesus Villamor survived the war and became one of the founders of Philippine Airlines, and he remained an advocate for Filipino aviation throughout his life. He occasionally spoke about the rebuilt P-40s in interviews, but always emphasized the pilot's courage rather than the mechanic's achievement. In 1977, a Filipino aviation historian researching the Philippines campaign discovered references to the rebuilt P-40s in declassified American technical intelligence reports. The historian Roberto Santos tracked down Kalugas through Philippine Army Air Corps records and interviewed him extensively about the project. Santos was amazed by what he learned. 19 aircraft written off as total losses, rebuilt without spare parts using improvised materials and techniques. 8 months of work in a hidden jungle workshop under constant threat of Japanese discovery, and at least 5 aircraft made flyable and used in combat operations. Santos asked Kalugas how he had learned to do such work, and Kalugas replied that it wasn't anything he had learned. It was simply how mechanics worked in the Philippines. When parts weren't available, you made them. When tools didn't exist, you improvised them. And when the manual said something was impossible, you tried it anyway and learned whether it was actually impossible or just difficult. Santos published a paper about the rebuilt P-40s in a Philippine military history journal in 1980, bringing the story to light for the first time. The paper attracted some attention from aviation enthusiasts and historians, but remained relatively obscure because it was published in a specialized journal with limited circulation. In 1985, the Philippine Air Force invited Calugas to a ceremony honoring Filipino veterans of the war, and at that ceremony, he was finally awarded the Distinguished Service Cross. The citation recognized his extraordinary achievement in maintaining aircraft under impossible conditions and his contribution to the Philippine resistance. Calugas was 71 years old by then, still sharp mentally, but his hands showing the effects of decades of mechanical work. At the ceremony, he was asked if he had any regrets about his time in the mountains, and he said his only regret was that they hadn't been able to rebuild all 19 aircraft. He believed that with more time and slightly better resources, they could have made at least a dozen P-40s flyable, and that might have made a real difference in the resistance effort. The historians at the ceremony gently pointed out that keeping even 5 fighters operational for 8 months without any spare parts was already an impossible achievement. Calugas smiled and said that Filipinos had been achieving impossible things for generations. It was just that nobody usually wrote about it. Jose Calugas died in 1994 at the age of 80, and his obituary in the Manila newspapers mentioned his Distinguished Service Cross and his work during the war. But it didn't fully explain what he had accomplished, and most readers wouldn't have understood the significance even if the details had been included. To understand what Calugas achieved requires understanding the complexity of aircraft maintenance, the sophistication of P-40 systems, and the impossibility of the task he faced. The P-40 Warhawk was a complex machine with thousands of components, each designed to precise specifications and manufactured to tight tolerances. The maintenance manual ran to hundreds of pages, and proper maintenance required specialized tools, diagnostic equipment, and access to factory parts. When aircraft were damaged beyond a certain point, they were supposed to be returned to depot-level facilities where trained technicians with proper equipment could rebuild them. The idea that a mechanic could rebuild such aircraft in a jungle clearing with hand tools and improvised materials was considered absurd by American standards. Yet that's exactly what Calugas did, not once but multiple times, taking aircraft that had been officially written off and making them flyable again. He did it through a combination of technical knowledge, mechanical intuition, improvisation skills, and sheer determination. He understood how aircraft systems worked at a fundamental level, which allowed him to devise workarounds when proper parts weren't available. He had the mechanical skills to fabricate components from raw materials, shaping metal by hand to create parts that matched the function, if not the form, of factory components. He had the knowledge of alternative materials and techniques gained from years of maintaining equipment in resource-poor environments. Most importantly, he had the mindset that problems could be solved even when the solution wasn't obvious, and that adequate solutions were better than no solutions. This mindset was fundamentally different from the one taught in American maintenance schools, which emphasized following procedures and meeting specifications. American mechanics were trained to be excellent technicians, but they were not trained to be innovators or improvisers. When faced with a situation where the manual's solution wasn't available, many American mechanics would simply declare the problem unsolvable. Calugas and his Filipino mechanics approached problems from the opposite direction. They assumed every problem had a solution, and they just needed to find it. This difference in mindset explains why American forces abandoned the 19 P-40s as total losses, while Calugas saw them as salvageable aircraft. The Americans looked at what they didn't have: no spare parts, no proper tools, no depot facilities, and concluded the aircraft couldn't be repaired. Calugas looked at what he did have: salvageable components, skilled mechanics, basic tools, and local materials, and concluded the aircraft could be repaired. Both perspectives were reasonable given their respective training and experience, but only Calugas's perspective led to action and results. The story of the rebuilt P-40s raises interesting questions about military doctrine, maintenance philosophy, and the role of improvisation in warfare. Modern militaries emphasize standardization, procedures, and specifications, and these emphases exist for good reasons as they ensure reliability, safety, and consistency. But they also create rigidity and reduce adaptability. And when military forces operate in environments where supply chains break down, standardization becomes a liability. Equipment sits unused because proper parts aren't available, even though improvised repairs might make it functional. Kalugas's achievement suggests that military maintenance doctrine should include a place for controlled improvisation, especially in austere environments. Mechanics should be trained not just to follow procedures, but to understand principles well enough to devise alternatives when procedures can't be followed. They should be equipped with basic fabrication tools and given permission to attempt repairs that fall outside normal specifications. Obviously, such improvised repairs would need to be carefully evaluated for safety, but the alternative, leaving equipment unserviceable, often represents a greater risk. Some modern military forces have begun to recognize this reality, and special operations units, which often operate far from supply chains, emphasize improvisation and adaptability. Mechanics assigned to these units receive training in field expedient repairs and are encouraged to think creatively about solving maintenance problems. But for conventional forces, the emphasis remains on following procedures and waiting for proper parts, even when that approach means accepting unnecessary operational limitations. The rebuilt P-40s also demonstrate the importance of local knowledge and cultural context in military operations. Kalugas's success wasn't just about his individual skills, it was about the broader culture of improvisation that existed in the Philippines due to economic circumstances. Filipino mechanics had learned through necessity to maintain equipment without reliable access to spare parts, and this created a body of practical knowledge that proved invaluable during the war. American forces that partnered effectively with local personnel often gained capabilities they couldn't achieve alone. The Filipinos brought knowledge of local materials, understanding of what could be obtained through local networks, and practical skills developed through years of resource-constrained operations. The Americans brought technical knowledge, understanding of aircraft systems, and access to whatever limited resources could be obtained through military channels. The combination was more effective than either group could have been separately, yet this kind of collaboration was relatively rare during the war. American forces often operated in isolation from local populations, assuming their superior training and equipment made local assistance unnecessary. This assumption cost them opportunities to leverage local knowledge and capabilities that could have enhanced their effectiveness. Kalugas's story also highlights the role of individual initiative in warfare, as he made the decision to stay and attempt repairs without any authorization from higher command. He committed himself and his mechanics to a dangerous project with uncertain prospects of success, and he did so because he believed it was possible and important. Military organizations generally discourage this kind of independent action because it creates coordination problems and can lead to wasted effort or dangerous situations. But in situations where communication with higher command is impossible and local conditions demand immediate action, individual initiative becomes essential. The challenge for military organizations is finding the right balance between maintaining centralized control and allowing subordinates the freedom to act independently when necessary. Modern military doctrine addresses this through concepts like mission command, which emphasizes giving subordinates clear objectives while allowing them flexibility in methods. But even with mission command, there's tension between the need for control and the need for flexibility, and it's a tension that can never be fully resolved. What can be said is that Kalugas's initiative produced results that would never have occurred if he had simply followed orders and evacuated with the American forces. The psychological impact of the rebuilt P-40s deserves consideration as well, as the appearance of American fighters months after the fall of the Philippines had significant effects on both sides. For the Filipino resistance, it proved that effective opposition to Japanese occupation was still possible, and it demonstrated that resourcefulness and determination could overcome material disadvantages. The fighters became symbols of resistance, physical evidence that the Japanese hadn't completely conquered the Philippines. For the Japanese, the mysterious P-40 attacks created uncertainty and forced them to allocate resources to air defense, even in areas they thought were secure. They never discovered the source of the attacks, which meant they had to assume the Americans had capabilities they couldn't account for. This psychological warfare dimension was probably more valuable than the material damage the P-40s inflicted, though both contributions were significant. The technical aspects of Kalugas's achievement also merit deeper examination, particularly his approach to engine rebuilding. The Allison V-1710 was a sophisticated engine that represented the cutting edge of 1940s aviation technology, and it was designed to operate at high power levels with precise tolerances. Rebuilding such engines without proper tools or measuring equipment should have been impossible, yet Kalugas did it multiple times. His success came from understanding the engine's operating principles rather than just following rebuild procedures, and he knew that engines tolerate considerable variation in specifications as long as certain critical relationships are maintained. For example, piston-to-cylinder clearances need to be within a certain range, but the exact clearance matters less than ensuring consistency across all cylinders. Valve timing needs to be precise, but it can be set accurately by measuring piston position and valve lift rather than by using specialized timing tools. Fairing clearances need to be correct, but can be checked using shim stock and careful measurement rather than precision micrometers. Kalugas used these principles to rebuild engines that met functional requirements, even if they didn't meet factory specifications exactly. The engines produced less power than they should have, and probably wouldn't have lasted as long as properly rebuilt engines, but they ran reliably enough for the missions required. This pragmatic approach to engineering represents a different philosophy than the one taught in formal technical training. Engineering education emphasizes precision, specifications, and meeting exact requirements, and this emphasis produces excellent results when resources allow it. But it can also create engineers who are helpless when exact requirements can't be met, unable to recognize that good enough solutions often exist. Kalugas represented a different engineering tradition, one based on practical problem-solving rather than theoretical optimization. He understood that the perfect is the enemy of the good, and that adequate solutions delivered quickly are usually better than perfect solutions that never arrive. His airframe repairs demonstrated similar pragmatism, as the P-40's aluminum structure required specialized techniques to repair properly. Aluminum can't be welded with ordinary equipment, and structural repairs normally required riveting, with precisely sized rivets installed with proper tools. Kalugas used whatever rivets were available and improvised installation tools when proper rivet guns weren't accessible. The repairs weren't as strong as factory work, but they were strong enough to handle flight loads if the aircraft avoided violent maneuvers. He accepted these limitations and briefed the pilots accordingly, making clear that the rebuilt aircraft couldn't perform aerobatics or combat maneuvers. This honest assessment of capabilities was crucial to the operation's success, as it ensured pilots didn't push the aircraft beyond what the repairs could handle. The use of parachute silk for control surface covering was perhaps the most audacious of Kalugas's improvisations. Aircraft fabric has specific properties related to strength, weight, and aerodynamic smoothness, and parachute silk was never intended for this application. But Kalugas recognized that parachute silk met most of the requirements. It was strong enough to handle the loads, light enough not to affect balance significantly, and could be made reasonably airtight with proper treatment. The tree sap and alcohol mixture he used as a coating was probably similar to traditional coatings used in Asian boat building, adapted for a completely different purpose. This kind of cross-application of techniques from different fields is characteristic of innovative problem-solving, seeing connections between seemingly unrelated domains. Kalugas didn't think of himself as innovative. He thought he was just using techniques that were common in the Philippines, but that perspective itself was part of what made him effective. He didn't see his solutions as desperate improvisations, but as normal problem-solving, which gave him confidence to attempt repairs others would consider impossible. The salvage operations that supported the repair work were dangerous and required careful planning and execution. Teams had to identify crash sites, assess whether they contained useful parts, plan routes that avoided Japanese patrols, and execute recoveries quickly and quietly. They were helped by local villagers who provided intelligence about Japanese movements and warning of approaching patrols. This network of civilian supporters was essential to the operation's success, providing security, supplies, and information that the mechanics couldn't obtain themselves. The relationship between the mechanics and the local population was symbiotic. The villagers supported the mechanics because they represented continued resistance to Japanese occupation. The mechanics provided hope that liberation might eventually come, and their presence in the mountains meant the war wasn't over despite Japanese claims of total victory. This civilian support network never appeared in official military records, but without it, Kalugas's operation would have been impossible. The Japanese would have discovered the hidden aircraft within weeks, and the mechanics would have been captured or killed long before completing any repairs. The fact that the operation continued for 8 months in Japanese-occupied territory speaks to the effectiveness of Filipino civilian resistance. Looking at the broader context, Kalugas's achievement can be compared to other examples of improvised aircraft maintenance during World War II. The Soviet Air Force famously kept aircraft flying under extremely difficult conditions during the German invasion, often using improvised repairs and salvaged parts. The Royal Air Force maintained operations in North Africa despite supply difficulties, developing field repair techniques that kept fighters operational in harsh desert conditions. The German Luftwaffe performed remarkable maintenance work, keeping aircraft operational as their supply situation deteriorated in the later years of the war. But none of these examples quite match what Kalugas accomplished, as those operations had some access to spare parts, even if limited. They had communication with higher headquarters and could request specific items. They had trained personnel who understood the aircraft they were maintaining, and they operated with official authorization and support. Kalugas had none of these advantages. No spare parts at all, no communication with friendly forces, no official support, and he was working on aircraft designed by a foreign manufacturer. The closest parallel might be the improvised aircraft operations of various resistance movements, but even those usually involved simpler aircraft and had some external support. What Kalugas achieved appears to be genuinely unique in the history of World War II aviation, rebuilding complex fighters from wrecks without any proper resources. The fact that this achievement remained largely unknown for decades reflects broader patterns in how military history is recorded and remembered. Official histories focus on major battles, strategic decisions, and the actions of senior commanders, while the work of enlisted personnel and support units receives minimal attention. Operations that occurred outside official channels often weren't documented at all, and achievements by non-American personnel in American campaigns were frequently overlooked. The combination meant that Kalugas's story fell through multiple cracks in the historical record. It wasn't part of official American operations, it involved maintenance work rather than combat, and it was accomplished by Filipino personnel who weren't integrated into American command structures. Only the chance discovery by a Filipino historian decades later brought the story to light, and even then it remained relatively obscure. This pattern is unfortunate because stories like Kalugas's provide valuable lessons about adaptability, improvisation, and the importance of technical skills in warfare. Modern militaries could benefit from studying his methods and understanding the principles that made his success possible. In recent years, military organizations have shown increased interest in operations in contested and austere environments where traditional supply chains may not function. This interest has led to renewed focus on expedient repair techniques, additive manufacturing for producing replacement parts, and training personnel to work independently of normal support structures. Kalugas's story provides a historical example of what's possible when skilled personnel are given the freedom to innovate under pressure. His methods wouldn't translate directly to modern aircraft, which are far more complex than P-40s and rely heavily on electronics that can't be easily improvised. But the underlying principles remain relevant. Understand systems deeply enough to devise alternatives, use available materials creatively, accept adequate solutions rather than waiting for perfect ones. These principles could be applied to maintaining modern equipment in situations where normal support isn't available. The human dimension of Kalugas's story also deserves emphasis, as he wasn't a specially selected elite operator or a highly trained specialist. He was an ordinary mechanic who found himself in extraordinary circumstances and rose to meet them through skill, determination, and creative thinking. His 47 Filipino mechanics were similarly ordinary people who accomplished extraordinary things because the situation demanded it. They worked in dangerous conditions, under constant threat of discovery, with minimal resources and no guarantee of success. They persevered because they believed their work mattered, because they wanted to continue resisting Japanese occupation, and because their skills gave them the ability to contribute. This kind of sustained effort in the face of enormous obstacles reflects qualities that military organizations value but struggle to develop systematically. Resilience, adaptability, technical competence, and commitment to mission can be encouraged through training and leadership, but they ultimately depend on individual character. Kalugas and his mechanics possessed these qualities, and they demonstrated them under conditions that would have defeated less capable people. The question of why this story remained so obscure for so long is worth considering, as it wasn't classified at high levels or deliberately suppressed. The technical intelligence report was classified, but only at routine levels, and the story could have been publicized without revealing sensitive information. The most likely explanation is simply that nobody in a position to publicize it recognized its significance or considered it worth documenting. To American officers processing technical reports in 1945, the rebuilt P-40s were a curiosity, an interesting example of field improvisation, but not strategically important. To Filipino officials after the war, Kalugas's work was overshadowed by the dramatic stories of combat and resistance that seemed more heroic. Mechanical work, no matter how skilled, didn't have the same narrative appeal as combat actions or dramatic rescues. This reflects a broader cultural bias toward action over support, toward combat over maintenance, toward officers over enlisted personnel. These biases shape which stories get told and remembered, and they result in a distorted historical record that emphasizes certain contributions while ignoring others. Kalugas himself contributed to his obscurity by his modest personality and reluctance to promote his achievements. He genuinely didn't see what he had done as extraordinary, and he was uncomfortable with attention or praise. This humility was admirable, but meant he didn't advocate for recognition of his work or ensure it was properly documented. If he had been more self-promoting, his story might have been preserved and publicized much earlier. The mechanics who worked with him shared similar attitudes, viewing their work as simply doing their jobs rather than accomplishing something exceptional. This cultural modesty, while personally admirable, contributed to the historical neglect of their achievement. Today, with increasing interest in unconventional warfare, resistance operations, and technical improvisation, Kalugas's story has greater relevance than it might have had in previous decades. Military planners recognize that future conflicts may require operations in environments where traditional supply chains don't function and where forces must be largely self-sufficient. Understanding how Kalugas and his team succeeded under such conditions provides insights that could inform modern doctrine and training. The specific techniques he used may be outdated, but the approach, the mindset, and the principles remain applicable. Perhaps the most important lesson is that technical specifications and maintenance procedures are tools to achieve operational capability, not ends in themselves. When following procedures becomes impossible, personnel need the knowledge and confidence to develop alternatives that achieve the same functional goals. This requires deeper technical understanding than simply following instructions, requires creativity and problem-solving, and requires willingness to accept calculated risks. Military organizations struggle with this balance because they rightly emphasize safety and reliability. But excessive risk aversion can lead to accepting unnecessary limitations. Kalugas's example suggests that with proper evaluation and testing, improvised repairs can be safe enough for operational use. His aircraft flew dozens of missions without any accidents caused by mechanical failure, despite being held together with improvised parts and techniques. This safety record was achieved through careful testing, honest assessment of limitations, and briefing pilots on what the aircraft could and couldn't do. The approach was professional, even though the methods were unconventional, and the results justified the risks taken. Another lesson involves the importance of preserving and transmitting practical knowledge that doesn't fit neatly into formal technical documentation. Kalugas's skills came largely from informal apprenticeship with his father and other experienced mechanics, not from formal schooling. He learned by watching, practicing, and developing intuition about how mechanical systems behaved and what kinds of repairs would work. This kind of tacit knowledge is difficult to capture in written manuals or formal training programs, but it's often crucial to effective problem solving. Modern military maintenance emphasizes formal training and certification, which produces consistent results, but may not develop the deep practical knowledge that enables improvisation. Finding ways to preserve and transmit practical experience alongside formal education remains an ongoing challenge. The role of local materials and local knowledge also deserves consideration, as Calugas succeeded partly because he understood what materials were available in the Philippine environment. He knew where to find suitable metals, which plants produced useful resins, and how local craftsmen worked with various materials. This knowledge allowed him to adapt his repairs to what was actually available, rather than being limited to what maintenance manuals specified. Military forces operating in foreign environments often lack this local knowledge and miss opportunities to leverage locally available resources. Better integration with local personnel and greater effort to understand local resources could enhance operational capabilities significantly. The story also illustrates the importance of mission focus over procedural compliance, as Calugas understood his mission was to keep aircraft flying, not to follow maintenance regulations. When regulations prevented him from accomplishing the mission, he set them aside and did what the situation required. This doesn't mean regulations should be ignored casually, as they exist for good reasons, and departing from them requires careful judgment. But it does mean that personnel need to understand the purpose behind regulations, so they can make informed decisions about when exceptions are justified. Calugas made such decisions responsibly, evaluating risks, testing his repairs, and being honest about limitations. His approach was professional improvisation, not reckless experimentation, and that distinction is crucial. Finally, the story reminds us that warfare outcomes depend on countless individual contributions, many of which never receive recognition. For every pilot who flew combat missions, there were mechanics who kept their aircraft flying, armorers who loaded their weapons, and intelligence officers who briefed them on targets. For every combat unit in the field, there were supply units, transportation units, medical units, and administrative units that made their operations possible. Most of these contributions go unrecorded and unremembered, but they were essential to whatever success was achieved. Calugas's story emerged from obscurity by chance, but thousands of similar stories never emerged at all. Every war involves countless individuals who solved impossible problems, improvised solutions, and kept operations functioning against all odds. Most will never be known to history, but their cumulative contributions determined outcomes as surely as any battle. José Calugas was one of these individuals, and he was fortunate that his story eventually came to light. His achievement rebuilding 19 P-40 fighters from wrecks without spare parts in a jungle workshop under Japanese occupation stands as one of the most remarkable maintenance accomplishments of World War II. It demonstrated that technical expertise, practical knowledge, creative problem-solving, and determination can overcome seemingly insurmountable obstacles. It proved that adequate solutions delivered quickly are better than perfect solutions that never arrive, and that specifications are guidelines, not absolute limits. It showed that local knowledge and improvisation skills can be as valuable as formal training and proper equipment. Most importantly, it illustrated that ordinary people in extraordinary circumstances can accomplish truly exceptional things when necessity demands it. The 5 P-40s that flew combat missions represented more than just repaired aircraft. They represented the refusal to accept defeat. They represented the determination to continue fighting even when official military forces had evacuated. And they represented the ingenuity and skill of Filipino mechanics who refused to let impossible obstacles stop them. Every time one of those aircraft took off from the hidden jungle airstrip, it was a victory against material limitations, procedural restrictions, and enemy occupation. That Calugas and his team kept this operation running for 8 months without support, without recognition, and without certainty that their work would ever matter is testimony to their character and commitment. They worked because the work needed doing, not because they expected rewards or recognition, and they succeeded because failure wasn't an option they were willing to accept. In the end, that mindset, that refusal to accept limitations, that determination to find solutions no matter how difficult, mattered more than tools or parts or formal procedures. It's a lesson that remains relevant today, as military organizations face increasingly complex challenges and operate in increasingly constrained environments. Technical competence matters, proper equipment matters, adequate supplies matter, but when those aren't available, human ingenuity and determination matter more. Kalugas proved that in the Zambales Mountains between April and December 1942, when he and 47 Filipino mechanics did what every expert said was impossible. They took 19 wrecked P-40 fighters that had been officially written off as total losses and made 5 of them fly again. They did it without spare parts, without proper tools, without factory support, and without permission from anyone who had authority to give it. They did it because they believed it could be done, because they had the skills to do it, and because they refused to accept that the alternative was acceptable. That achievement deserves to be remembered, not just as a footnote to the Philippines campaign, but as one of the great improvised engineering accomplishments of World War II. It deserves to be studied by military maintainers, engineers, and leaders who may someday face similar challenges. And it deserves to stand as testimony to the skill, courage, and determination of Filipino mechanics who fought their war with wrenches and ingenuity. If you found this story as compelling as we did, please take a moment to like this video, as it helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories, because each one matters, and each one deserves to be remembered. And we'd love to hear from you, so leave a comment below telling us where you're watching from.